Welcome, ladies and gentlemen, to your next installment of Algebra 1. Today we're going to be going over a pretty basic building block of Algebra 1, that's solving one-step equations, but it is going to set us up for success with more complicated things. So it might seem like we're going a little bit slow at the beginning here, but trust me, the things that we're doing right now are going to be the foundation of what we do later, all right? So again, these notes are made for you. Use them as you will, and also pay attention to the timestamp. So if you look below in the description, you should be able to see some timestamps that I put in there, and I will timestamp every single example. Probably not for the warm up here, but later on when we get to example 1 and 2 and 3 and so forth, I will timestamp those so you can go ahead and go right to those. All right, the warm up here, which you may or may not have already completed. I'm going to go through step by step. So number one, these are just evaluating, right? So when we evaluate, remember we're using the order of operations. So parentheses, exponents, multiplication, division, addition, and subtraction. So when I'm looking at 14 times 4 plus 7, that is in parentheses squared. Parentheses gets taken care of first. Now, inside this parentheses, I have a choice. I can multiply or add. And multiplication is needing to be done first because multiplication comes before addition. So the very first step that I do is multiply 14 times 4, and that gives me 56. Now I only have one thing left to do inside those parentheses, and that is add. So 56 plus 7 is 63. And then the last thing that I do there is square. I do get a large number, and that is 3,969. The next one, again, whenever we have large fraction problems like this that we're simplifying, we always want to work left to right. So notice I got long rectangles here because I am working left to right. The other thing I want you to remember is that these are grouping symbols. The radical itself, some of you might just call this the square root bar, but it's really called a radical. The radical itself is a grouping, which means you have to think about this as if it's in parentheses because it really is. And so think of it like that, right? And so that is the first thing that I'm going to compute, and I'm going to do everything one at a time. So the first thing I do is add 3 plus 6. And notice everything else I have written down, right? So everything else is there. Then next thing, I'm going to finish everything in the numerator. The other thing is that we have to remember that the grouping is also extended to the numerator and denominator. So everything in the numerator is in a group as if it's in parentheses, and everything in the denominator is in the group as if it's in parentheses. So I'm just going to finish off the numerator here. So that means I'm going to go ahead and square, take the square root of 9, which is 3, and then I'm going to add 5 plus 3 to get 8. And notice I haven't even touched the denominator yet. Okay, so get rid of that one. And then I'm going to start working on the denominator. So I have choices, right? Do I square? Do I add -5 to 4 squared without squaring, which is hard to do? Or do I multiply? And again, order of operations tell me to do the exponents first. So I do that, and I get 16. Notice that's the only thing that I've done there. Actually, I've gone ahead and multiplied 2. And truth be told, that works out okay there because multiplication comes before addition and subtraction. So I've done that in the same step. When I simplify this, I get 16 minus 10 to get 6, and then I have to simplify that fraction. So the actual answer here is 4 over 3. All right, cool. The next one is an example of evaluating when we have variables, right? So I'm told that A is supposed to be equal to -3. That means this -3 goes in for A right there. And remember, whenever we substitute, we use parentheses. So substitution looks like this. Whoop, that's not what I wanted to have happen. -3 goes in for A, and then I'm substituting everything. I'm substituting that value in. That's in blue here. And now that it's substituted, I just follow the order of operations. So again, I got parentheses. That comes first. So I take the -3 plus 7. That is the same as saying -3 plus 4. I'm sorry. Same as saying 7 minus 3. Distracted here. So I get 4. And then I have to compute the exponent. That comes next outside of parentheses. So 4 squared is 16. And then I just have to add the 5 plus 16 to get 21. All right, so that is the warm-up there. And number 4, warm up, again, same idea, but again, just a little bit more complicated. So the x is equal to 9. 9 goes in for x here and here. And then y is equal to 7, which means 7 goes in for y in both locations. So in substituting, 9 is in for x, 7 is in for y. And then in my next step, I just start tackling the numerator and denominator. Remember, they're in groupings. So I tackle them both at the same time here. They do not impact each other until I actually divide. So I was able to take 9 plus 7 to get 16, 9 minus 7 to get 2. Carry the square, right? 16 divided by 2 is 8, and then I take 8 squared, and bada bing, I get 64. And then these, I'm not going to talk too much about these. Just remember, I'll show you the answers here. You can pause if you'd like to take a look. But remember, there is a difference between -3 squared in parentheses to give us the positive 9. Remember, that means -3 is being multiplied by itself twice, and then negative times a negative is positive. But in this scenario, we get a different answer because this translates to -1 times 5 being squared, so 5 times 5. Turn that off. So that's how we end up with the -25 here. And then also multiplying by -4. Negative times a negative is positive 100. And I think the rest of them are pretty self-explanatory. So I don't have to really talk much about that. Also, I guess I'll talk about this one. Remember that we're adding a negative here. So subtracting a negative is the same as adding the opposite. So we're really doing 8 plus 5 to get 13. Okay. So let's get on with the lesson. So example here that will work out together, this thought process. Eric is thinking of a number. He added 7 to that number, and then he took that result and divided it by 2. He took that result and then multiplied by 5 to get 40. What number is Eric thinking of? All right, so this sounds like something that we need to break down because it's pretty confusing if we try to take it all at once. And so let's break it down sentence by sentence. Eric is thinking of a number. Let's assign a variable to that number, and let's just call it whatever, W. Okay? He added 7 to that number. Let's take the sentence at a time. So what did he do? He took W, whatever that is, right? And he added 7 to it. So let's just do that. W plus 7. He then took that result and divided it by 2. So we took the result of W plus 7 and then divided it by 2. Now, if I want to make sure that W plus 7 gets done first, I have to put that in parentheses. And then I'm going to take that and divide that by 2. So I can do that several ways. I can take W plus 7 divided by 2 like that, or I can take W plus 7 in parentheses and say then divided by 2. I can work both those scenarios. So we've got that sentence taken care of. He then took that result and multiplied it by 5, and he got 40. So I'm going to split this up right there and say he took the result, so basically this part, and he multiplied by 5. Well, what does that look like? That means I got to take this whole thing and multiply it by 5. And when I was done, I got 40, or Eric here in this case. Kind of going ahead and modeling this part, kind of move myself here. If I wanted to do it like this, sorry, I gotta get my right pen, blue. I would have to put parentheses around this whole thing and then do the same thing, right? Times 5 equals 40. Okay? Well, what did we just do? We just took all of that, broke it down, and then created an equation. I needed a 0 there. So this is the type of thing that we can do with math. We can turn this type of problem into an equation and solve it. Now we can figure out what number they're thinking of. Okay? When we are done with the next few lessons, we will be able to handle this complicated of a problem. Today's purpose is to handle one-step equation. That's where we're starting. Okay? So we want to think of equations as a scale. Okay? So we're not really going to do this problem here, but think about what you would have to do. Like, what would be the value of x to make the statement true? Okay, and so let me give you a little front loading, right? So like if I said that, well, I have an equation, and the equation is x plus 3 equals 7. Okay, And if I gave you just that equation, without doing any mathematical processes, you might just start guessing and checking. You're like, well, does 2 plus 3 give me 7? Does 3 plus 3 give me 7? 4 plus 3 gives me 7. And you go through some of that kind of process like that. And then I could make it more complicated. Well, what if that's now 2x, right? Well, what would that look like? And then you could start doing the same kind of checklist. And if I get to something like this, it's pretty clear that guessing and checking isn't a really good strategy. So what we need is a strategy to solve these equations, okay? And the biggest thing that we're going to get out of today is that when we are solving equations, whatever we do to one side of the equation, we have to do to the other, which should be a mantra that you've heard before. It's definitely something that we want to do, okay? So we got to keep the equation, right? We got to keep the equation always in balance. So if I add 2 to one side of the scale, right, well, I better add 2 to the other side. We want to think about that in terms of an equation as well. So let's practice that for a second, okay? And I'm also going to start developing here a thought process that is very, very important that you will carry on even to advanced algebra, okay, and FST and pre-calc. I just spoke with those teachers the other day, and they said they still use the process that we fundamentally teach you as a foundational skill in Algebra 1. So make sure that this is something that you know. So we want to find the value of x in the equation. We always start with this question, and we answer this question. What is happening to x? Okay? That's where we start. So what's happening to x? Well, what's happening to x is that we are adding 9, right? And whenever we solve equations, we have to undo that stuff. We have to undo what was happening to x in order to find out what x really is. And in order to undo things, we have to do the inverse operation. So the inverse is like the opposite, right? So if we added 9 to go forward, right, the order of operations would tell us like, oh, take whatever x is and add 9 to it. We have to undo that with the inverse operation. So what's the inverse operation of adding 9? Well, it is subtracting 9. And whatever I do to one side of the equation, I must do to the other. I'm going to undo that equal sign there. That's not what I meant to draw. What I'm doing is drawing a line through the equal sign so I can see visually which side of the equation I'm talking about. When we get the longer equations, it's very helpful. So subtract 9 from both sides. So now, if I subtract 9 from both sides, I know that x, 9 minus 9 just gives me x, right? 21 minus 9 then gives me 12. All right, so 2 things, right? Always start by asking what is happening to the value of x, what is the inverse of that operation, and then complete that inverse on both sides of the equation. Okay, so equation here, first one. This is going to be the model that we use. If you look at your independent practice, and now it's obviously in your notes, this is the model we use. So we have the equation, and we ask, what are the forward steps? What if you were to follow order of operations? What happened to x? It's all the same thought, right? So what happened to x in this one? Solving steps, it's reversing what happened. It's undoing what happened to x, right? So reverse and undo. Right now, we're really going to just focus on the undo. Reverse is kind of more for the two-step equations. And then we're going to show our work for that. So what are the forward steps? We are adding 24. What do we do to undo that? What is the inverse of that? The inverse of that is subtracting 24, okay? And so then I complete that. I write out the equation, x plus 24 equals 31, and I execute whatever is here. Whatever's here is literally the directions that we're going to follow. So I'm going to subtract 24 from both sides. Again, I don't want that equal sign there. My bad. I'm going to draw a little dotted line so I can see each side. I'm going to draw a line to show that I'm done with that step, and I'm going to have x is equal to 7. Okay. Next example, same exact process. What are the forward steps? What is happening to x? I am subtracting 15. How do I undo that? I add 15. Again, this box tells me what steps to complete. Move myself here. And so I'll rewrite the equation. X minus 15 is equal to negative 21. Then I will add 15 to both sides, plus 15. And I will get x equals negative 6. I also like to box my answers, so it's really easy for me to tell where I'm at. Okay, so that is example 3. Example 4. All right, well, what's happening here? What is happening to the x? I am now multiplying by 7. So I like to abbreviate that, multiply by 7. How do I undo that? What is the inverse of multiplication? The inverse of multiplication is division. So divide by, abbreviation, 7, and then go ahead and execute the work. So 7x equals 56. When I divide by 7, I do not write the division symbol here. What I do is I write it as if I'm doing a fraction, right? That's the same as divided by. So 7 divided by 7 gives me 1. That's the 1x that I'm looking for. There's my dotted line. Divide the other side by 7. Whatever I do to one side, I do to the other. Showing that I'm done with that step. Now I'm going to compute 56 divided by 7, and I get 8. Next example. What is happening to the x here? I am dividing x by 5. How do I undo that? I multiply by 5. So, rewriting the equation, x divided by 5 equals 30. Now I go ahead and execute this step. I multiply both sides by 5. The way I do that is showing that, well, if I divide it by 5 in this fashion, I write times 5 in the numerator. That will cancel out the 5s. 5 divided by 5 is 1. Just like in here, 7 divided by 7 was 1. That gives me the 1x. This gives me the 1x, right? And whatever I do to one side, I do to the other. So times 5 again over here. That shows that I'm done with that step. There's my side that tells me which side the equations are on. And that 30 times 5 gives me 150. All right, moving right along here. What's happening to the x? I am subtracting 5. How do I undo that? I add 5. And then here's my example for the work, right? So x minus 5 equals negative 8. I'm going to follow the steps here. So plus 5, plus 5. That leaves me with x equals negative 8 plus 5 is negative 3. Next example, I have 5 times x. So what is happening to x? I am multiplying by 5. How do I undo that? I am dividing by 5. That is the inverse operation of multiplication. And then I'll execute that. 5x is equal to 20. Divide both sides by 5. I get x is equal to 4. All right, one more set of examples, and we're going to be done with this video. Pretty short today. What's happening to x? I'm dividing by 7. So divide by 7. How do I undo that? Inverse operation of division is multiplication. So I'm going to multiply by 7, and then I'll execute. X divided by 7 equals negative 28. I will multiply both sides by 7. Undo that. And again, remember, this gives me 7 divided by 7, which is 1. And it gives me the 1x that I'm looking for, right? So x is then equal to, I got to do this one. I don't know this off the top of my head. 196, and it's negative because it's negative 28. So negative 196. All right. Last problem here. What is happening to x? I am dividing by 6. How do I undo that? I am going to multiply by 6, and then I'll execute. X divided by 6 is equal to 84. How do I undo that? Well, I follow these steps, right? I go ahead and multiply both sides by 6. Again, I get that 1x part there. Whatever I do to one side, I do to the other, times 6. I get x is equal to, then that is going to be 504. All right, so hopefully this video was helpful for you. Make sure that you have completed your independent practice, and if you're unsure what that is, check Schoology for that. And if you would need more help, make sure you always stop in and ask your teacher. Have a great night.